Schools, they have announced that from September 3rd, they'll start for us.
Okay.
So it will be a 9 to 4-ish.
Okay.
And yeah, it will be a Monday to Friday session. There's no alternate days for us.
Okay. Okay, we'll see. What I'm thinking is September 1st, government is allowing the schools to be opened by September 1st. So I'm thinking this September 1st, this week we will continue with the, oh, I'm not sharing the screen. Okay. So this week, we'll continue with the online class, okay, this week and next week. And from September 5th, we'll see, September 6th, maybe we can see, if we can call you for the center or see how we can, manage it. Okay, that's my plan. And I know some of you are long distance students, so I will have to, project the board. I'll see, last time I was doing something like that. We'll see how it works. So Elvin, I'm doing fine. Thanks for asking. So I'm having bad headache. So what do you want to do? You're going to continue with the class or not? You're not feeling well? Okay, continue as much as possible. Okay.
So what did you do?
Say that again.
Sir, not click join how it goes. Can you repeat what you said now, sir?
I'm not understanding your. What is your question?
So what were you saying, sir? I did not click join audio. I wasn't able to hear.
Oh, I was talking to Elvin. So Elvin said he is not feeling well. So okay, I said, he can stay as long as he feels, he is okay. Did you understand? Okay, very good. Okay, so my plan was to continue with the numericals. Again, the issue I am having is like, I've been taking a lot of classes, like, more than 4 or 5 classes in a day. So I'm talking for more than 5 hours or something. So because of that, sometimes, as when I'm doing the class itself, my throat becomes very dry and I'm not able to continue the class. So I'll try to talk a little bit less. I hope this NEET and JEE class will be over by this week. So after that, I will get some little bit, rest. So that's the reason sometimes my throat becomes very dry and I know it's a little bit hard for you folks. So I'll try my best. Okay, and I'll try to talk less. So if you have any doubts, please ask me. Okay, don't make me say that again and again. So if you have doubts, please ask me. I can explain it. Otherwise, I'll try to write as much as possible. Yeah, so let's see. So any problem, any exercise problems which you tried and you are not able to do it, please let me know. We can do that first. If you don't open your mouth and if you don't communicate, then I will be doing just whatever I think is important. If you open your mouth, you can get what you want. Okay, the other day we finished this page. Okay, I'm not going to spend any more time on this page. So my plan, I think I told you to do it as homework.
But if there's some theory type questions, if you have on this topic, can we do? Will we get any kind of theory in this? Or
Yeah, you will.
Be...
No, you will get theory questions also.
Okay, sir.
Yeah, we can do it. Numerical is also important. Theory is also important. Okay, these
yes,
22, 23 and all is theory questions. But generally, I like to do more of numerical in the class because theory, most of the time it will be easy. And if you see the solution, probably you will get the answer. You will understand the answer. So that's why I like to spend more time on the numerical. Okay, anybody tried something but not able to do it? Any questions? Please let me know. Uzma, did you try some problems?
Yes, sir. I did the first 5.
First 5, that's all. Okay, what about the remaining? Additional exercise, or you didn't do the additional exercise? Okay.
Yeah, I have to start, sir.
Okay. What about others? Did you try any of these problems? Okay, let's.
I tried 5.24.
19. To 418. Okay. You have any doubts?
And the most of the questions we had done it already in the class, the main numerical questions.
Okay. I see this interesting question. Let's try this. Again, I'm not going to do the entire problem. I'll give you only the guideline. You have to do it. A batsman deflects a ball by an angle 45 degree. So it means, let's say the ball is coming towards the batsman like this and then deflects by an angle 45 degree. So that means this is, and let's say you're deflecting it like this 45 degree. Actually, if this is like this, ball is supposed to go straight like this. So if I deflect it like this, this would be 45 degree. Okay, I think this is wrong. This is not deflecting 45 degree because the ball was supposed to go straight like this. Am I being audible? Everyone able to hear me? Because my mic is slightly away. So can you hear me? Okay.
Loud and clear.
Okay, very good. So the ball was going, when the bowler is, bowling from here, the batsman is standing here. So if the batsman was not hitting with the bat, the ball is supposed to go straight like this, right? Which means if I say the batsman is hitting the ball this way, then it got deflected this much, not by 45 degree. But if I say the ball is coming straight like this, but it's deflected like this, means, it's something like this. So that means it's getting deflected by 45 degree. So this diagram, I would say it's wrong. This would be the correct diagram. Without changing its initial speed, which means if it was coming with the speed of v, this is also going at speed of v, which is equal to 54 kilometers per hour. 54 kilometers per hour, you can convert it to meter per second. Okay, I'm not going to do the conversions for you. You can do it yourself. What is the impulse imparted to the ball? What do you mean by impulse? Anybody?
Change in momentum.
Change in momentum. Okay, more accurately, F into delta T, right? F is equal to mv minus mu by delta T. So I told you delta T comes on this side, the hammering example. So mv minus mu. So that means this is your impulse. Okay. So that means if I am able to calculate the change in momentum, I can calculate the impulse. But then here they said the velocity is same. So that means mass of the ball does not change. Velocity is same. That means, can I say this minus this is 0? Is that correct? Anybody? The magnitude did not change. So can I say this is going to become 0? So impulse is 0. Is that correct
Yes,
or
sir.
wrong? Correct. Any
Yes,
other
sir.
answers? Velocity, is it a scalar or vector?
Vector.
Vector.
How many times did I say when I'm talking with the theory? Are you supposed to do vector addition, vector subtraction, or scalar subtraction? Scalar subtraction. Is that right? Will you do scalar subtraction or vector?
Yes, so
subtraction?
scalar subtraction.
Velocity will do scalar subtraction.
Sure, sir.
Vector subtractions.
Still somebody is sleeping. So velocity is a vector, which means you are supposed to do vector subtraction, right? So if a ball is going this way and then this way, which means the resultant vector addition will look something like this, right? But then the vector addition will look something like this. Vector subtraction will be, how to do this. You know that the tails should be touching each other. The magnitude is same, which means the length should be same. So you know that this is vector addition, parallelogram law of vectors. So take it down, even though it's not required for this question. Understanding all these things is important for you. So this is your initial, this is your final. Why did I bring this? Because the tails should be touching each other. Only then you can do vector addition or vector subtraction. And vector subtraction would be looking something like this. So can anyone tell me what should I do? Should I put the arrow this way or should I put the arrow near this one or this one? 1 or 2, which one is correct? Look at the question and tell me. I want final minus initial. So final minus initial means which one? 1 or 2, which one is correct? A minus B. 2, very good. So that means final minus initial. So B minus A. Okay. So 1 is wrong. Okay. Remember, I'm talking about initial momentum, final momentum minus initial momentum. So if A and B is confusing, you can call this as P initial, P final. Okay. What am I supposed to find? What is the impulse imparted to the ball? That means I'm supposed to find this magnitude direction. So you know this one. So calculate the V and substitute here, you will get the answer. Okay, and find the C value. And then you are supposed to find the angle also. So if I remember the formula correctly, b sin theta, a instead of plus, it will be minus b cos theta. Theta will be 45 degree. This is p final. This is take it down. You can do it yourself later. So I'm trying to give you the concepts and methods. You have to do the maths. I don't have time to do the multiplication division. So do the math, check the answers. And if you are not getting it, we can discuss it later. Why are you finding alpha? Anybody? They didn't ask you to find the direction. Why should I find the direction? Anybody? Impulse is a scalar or vector?
Vector.
Vector, which means even if they don't ask you, right, you still have to calculate the alpha. Just to be on the safer side, I would say calculate the magnitude and angle. Okay. Go to the next one. Anybody still copying? uh, 5.21 is also easy one. Anything else? If you tried it and you are not able to solve, means you have to open your mouth. Otherwise, I don't know what to say. What about Veer, Siddharth? Did you try some other problems in your book? Do you have any NCERT problems tried out?
I tried few problems, but it wasn't enough.
Okay, what do you mean?
Like, because I have exams, I have to manage both.
Okay. Okay,
Yes, sir,
Aston.
because of exams lately I didn't do problems, but I tried
Okay.
few.
What chapters, what topics do you have for your exams in physics?
So the first
Five,
four, five, sir.
What is first five? Same like this one, up to Newton's laws? Laws of-
No, sir. Dimensional analysis is a separate chapter. So
Okay. So what is the last part, like up to motion in plane? Is that what
motion
it-
in a plane. Yes, sir.
Okay. So you know that the tension is equal to mv squared by r, right? This is your demand, and this is your provider. So when the tension goes beyond this value, then this wire will break. So that means the maximum will be T max. So the T max should not go beyond 200. Using this, I can calculate the maximum velocity with which I can spin. Either you can calculate the V and substitute it here, or you know that this m V is equal to r omega. So V is equal to r omega. So we have done this many times. So it becomes mr omega square. Mass is given 0.25 kg. Radius is given 1.5 meter. Omega, can I substitute 40 rev per minute? Can I substitute it, or should I do some conversion? Anybody? What is omega unit? Nobody knows. Omega is equal to radians per second. Okay. So for 40 revolutions, for one revolution, it is 2 pi radians. For 1 minute, it's 60 seconds. That means I'll be getting radians per second. And that is what is your omega. Generally, some textbooks will give, n is equal to this much. So omega is equal to 2 pi n by 60. N will be in RPM, revolutions per minute. But instead of mugging up this formula, you can logically understand this. One revolution means 2 pi radians. 1 minute means 60 seconds. That's why you're getting this formula, 2 pi n by 60. That means multiplied by 40, 2 pi by 60. Do the math and get the answer. Okay. So
I got around 4.2 is 4.2 is kg.
is that right? Tension, what is the maximum speed with which the stone can be whirled?
Oh, no, it's wrong. I did calculation wrong.
1.5 meter with the speed of 40. So in the first part, you will be calculating the tension like this. So Newton will be your answer. Anybody got this answer? Nobody got this answer? Okay, do it yourself.
So
Okay.
tension, maximum tension is I guess 200.
No, you are looking at the question and saying something. I'm talking about this calculation. 1 by 4 cancels. 1.5 into 2 is 3. 320, pi by 20. I think we'll get pi by 20. 6.4. Anybody else? I don't think it's 6.4.
6.6.
6.6.
Yes, sir. 6.6.
Is that what you're getting? Oh, okay. The zeros cancel. 3 1 by 4. 3 point divided by 6. 6.6 is everyone getting? 6.6 Newton. By 4 cancels. 3. 0 cancels. So 3 and 2 pi by 2. I'm getting pi by 2 here. What's the mistake I'm doing?
So omega square, no, sir.
Oh, okay. Yeah. All right. I made a mistake here. That's the difficulty with this, computer screens. Most of the time, I'm not able to see what is up here. Okay. Okay, so I will leave the math to you. If they say the maximum tension is 200, then put the value and find out the omega. And if you know the omega, you can calculate the n, capital N. Anybody not following? Can you do it yourself? Okay. I would say these are all easy ones. We talked about the horse cart problem. So try it yourself. If you have difficulty, we can discuss it. Okay. I would like to spend more time on the difficult ones. So try these theory questions yourself. Check the answers. Okay, try to understand. If you have difficulty, we can discuss. Okay, 5.24. Let's get started with the additional exercise.
So I have a doubt in one question, sir.
Yeah.
So in the 19th question, they have given the muzzle speed and this recoiling speed. So what is the difference between them, sir?
Okay, but did you get the answer correctly, or you're having trouble in the starting point itself?
No, sir. Like I got to know how to do it, but the muzzle speed and it's a little bit confusing.
Okay, shell of mass 0.02 kg is fired by a gun of mass 100 kg. Muzzle speed of the shell is 80 meter. What is the recoil speed? Okay, very simple. So imagine you have a rifle like this. That's your trigger. So the bullet is going to be somewhere here. And then when you press the trigger, the bullet is going to be flying through this. This part, I think this is what is called the muzzle. So that's why it's called muzzle speed. Okay. You know that the gun is going to get coming back, right? You know that. So
Yes, sir.
when you go to Chennai Marina Beach, try to shoot that balloons. It's a very interesting game. So do that. You will see that you have to hold your rifle somewhere in your shoulder. Only then you can control this recoiling. If you don't hold it in the shoulder, this entire gun will be thrown backwards. So why does that happen? You know that M1 U1 plus
Yeah,
M2.
the amount of force being given by the gun.
Yeah. So you can go back and check your Newton's third law. When the gun is giving a force on the bullet is giving a force on the gun. But the bullet is very, very small, something like 0.2 kg, or you see 0.02 kg, very, very small, which means it's into 1000, so 20 grams. Whereas the gun is something like 100 kg. It's a huge difference, which means that F is equal to ma. So even though the force is same, right? The force on the bullet and force on the gun are same. This is having a very, very small mass, which means the acceleration of the bullet will be very high, whereas the gun will be having a very high mass, which means the acceleration of the gun will be very low. And based on that, we derived law of conservation of momentum. Go back and check this, study this. So initially, bullet and gun are not moving. So U1 is 0, U2 is 0. Let's say this is bullet. The first one is bullet and the second one is gun. Okay. So this side becomes 0. M1 is bullet, so 0.02. V1 is velocity of the muzzle
80.
speed is 80. Yeah. So bullet speed is 80. M2 is 100. V2 is what is asked. So V2 is equal to minus 0.02 into 80 divided by 100. So do the math and you will see that V2, why do you think you are getting a negative? Anybody? Padmaja, why are you getting a negative here?
Because sir, it's equal and opposite.
No, the gun,
It's
look at velocity of the gun. Is it going forward or is it going backwards?
going backwards.
Backwards. So that's what this
Backwards.
minus represents. Gun going backwards. Okay, so take it down. That's all. So is it clear now?
Yes, sir. So, but before that, they're talking about the shell. So they're not talking about the gun, I guess. So I mean,
Shell,
not
this bullet
Oh.
or shell is the this small thing.
Okay.
That is what is your shell, right?
Okay. Okay, sir.
Okay. If you don't want to imagine the rifle, then you can imagine the, I don't know what is this called, the cannons, right? We'll have a cannon like this, and they will put
Yep.
Tipu Sultan kind of things. You must have seen this, the old history thing. So they will put some shell over here, and then they will put some gunpowder here. So when the gunpowder explodes, right, that will be a cracker kind of thing, like this thing. So the fire will go here, and then when the gunpowder explodes, the shell will be thrown out like this. So what they will do in entrance exam questions is they will combine this with your projectile motion. They will say that the cannon is kept at say 45 degree. What is the maximum distance it will go? Something like that. So using this, you will have to calculate the velocity, And from the velocity, you have to calculate the range, which, using your projectile motion concepts. Okay, if you don't want to imagine a rifle, you can imagine a cannon.
Yes, sir.
So there, instead of calling it as a bullet, we would call it as a shell.
Okay, sir.
Okay, any other doubts in this page before we go to the additional exercise? Again, if you try it and come, this class will be very interesting for you. If you don't try it, this class you will not be able to follow much. Okay, let's go to this one. I think this will be an interesting problem. Shows the position time graph of a body of mass 0.04 kg. Suggests a suitable physical context for this motion. What is the time between two consecutive impulses received by the body? Is the time between two consecutive impulses. So any idea what they are asking? What is the time between two consecutive impulses received by the body? So I think this is 2 seconds. So something is going from here, hitting here.
So every 2 seconds it goes up and goes down.
Yeah. What is the magnitude of each impulse? So that
I guess it will be the same, right? Because the pattern of this is the same for all lines.
Yeah, that is true. But if you find for the first one, you can say for the it's going to be the same for the next ones, right? So have they given force? Have they given any time here? They're not given force, which means I told you have to remember the change in momentum concept. So anyone can tell me how to find the velocity here? This is position. 2 by 2 will become 1. Is that right?
Yes, sir.
Here also it is 4 minus final minus initial. So that means it's 0 minus.
That's also 1.
So 1, but it's going to be minus 1, right? It's going in the opposite direction. So velocity will be minus 1. So mass is given. So 0.04. Let's talk about the first impact here, right? So let's call this as board A. So let's say there is a board here. So the ball is going here and then hitting and then coming back like this. So V minus U. So what is the final velocity here? Minus 1. What is the initial velocity? Plus 1. Okay, I think I made a mistake here. Minus is in the formula and then it's plus 1. So that means I should write it like this. Final minus initial. Minus 2, which means minus 0.08. So that is your impulse in the first. Similarly, you can do the same thing for impulse at this one. Let's assume that there is one more wall here. So the ball is kind of going back and forth. So that means it's hitting here and then it is hitting here. So this is B. But here you have to be careful. Look at this. This is initial, this is final. So this is final is V is equal to plus 1. So that means final is plus 1. So 0.04 mass does not change. So plus 1 is the final velocity. And initial velocity is minus 1. So initially, until you become comfortable, I would say just use these brackets properly. So this minus and minus will become plus 1, 1, 2, so 0.08. Can anyone tell me why there is a minus here and why there is a plus here? From the wall perspective, A is one wall, B is one wall. Why do you see a plus and minus? Anyone?
Sir, at A, which is on the top,
Hmm?
it's coming down back to the floor. You can say something like that.
What is coming down?
The mass.
No, yeah. I'm talking about the force here. Yeah, what you're saying is correct. So since the mass is coming down, what does that mean? The wall has pushed the ball
Yeah.
downwards. Whereas here the wall is pushing it upwards. So that's why here it is a minus and here it is a plus. So this is downwards. So the impulse given by the wall A is downwards. Here it is upwards. Any questions, any doubts? Magnitude of each impulse is same, 0.08. Newton second. Okay. Let's see. So Elvin, you are sharing some experiences of hitting the balloon in Marina Beach. If you want, you can share it with your friends. Okay, instead of me translating it from your chat window. No Marina Beach. Okay, where did you do that? Shimla. Okay.
So I had a doubt that
Yeah.
when suppose we are at a lower altitude, suppose we take Coimbatore, which is near to the sea level, and there's a gun shooting normally. So will there be a difference shooting at a lower sea level than going to a higher sea level?
Why would there be a difference? Whether you shoot it in Chennai or whether you shoot it in Ooty, why would there be a difference? Are you talking about pressure, temperature, these?
Yes, pressure wise.
Let's see. I know sound will have an effect, but a bullet, I don't think the effect is going to be, pressure and temperature.
The
is
sound, we can say that in the higher altitude, it will echo a lot.
Yeah. So sound will have an effect, but the bullet as such, it's not going to have any difference. It's going to be the same, same gunpowder exploding, right?
Fine.
I don't think that will have an effect.
Yes, sir.
Shows a man standing stationary with respect to a horizontal conveyor belt that is accelerating 1 meter per second. So that means this is accelerating 1 meter per second square. What is the net force on the man? So this is what I was talking about the other day. So when the car is going forward, you will get pushed backwards. So that means this man is going to get pushed this way. So when this is 1 meter per second square, this will also be 1 meter per second square. So the mass of the man is 65 kg, which means so F pseudo. So pseudo force backwards is equal to mass into acceleration. Mass is 65 kg. Acceleration is -1. If you want, you can put a minus. It will be minus 65 Newton. So that will be the force on the man, net force on the man. Oh, wait a minute. They are given some friction details. Okay. So this is only this force. So I calculated only the backward force. I have not calculated the friction force. The coefficient of static friction between the man's shoes and the belt is 0.2. So that means the coefficient of friction is up to what acceleration of the belt can the man continue to be stationary relative to the belt? So you know that F friction, anybody remember the formula? F friction is equal to, nobody remembers? Veer, what is the formula? F friction is equal to
Mu n, sir.
mu n, yeah. So what will be the normal reaction for this man? So this guy is 65 kg this way, 65 into 9.8, or you can say approximately 650 Newton, which means the normal reaction will also be upwards, which will also be 650 Newton. So that means mu is 0.2 into 650 Newton. 0 and decimal point goes away, so 65 into 2 will give me 130. So now tell me, so the F net will be, so friction is acting forward. Okay, I told you this is slightly confusing, so please pay attention. You may be wondering, sir, the belt is going forward, which means the friction should be backwards. Well, that is wrong. Because of the belt going forward, the man is getting, it's possible that the man will slide backwards. But who is keeping it forward, keeping him forward? Because of the friction between the shoes and the belt, which means the friction is what is, holding the man and the belt together, which means it is pushing it this way. Okay, this is a bit confusing, so take it down properly. And nothing is given up regarding this in your theory. So F net is equal to F friction is forward plus F pseudo. You can put plus here, and then in the next step you can put a minus. So here it is 130 minus 65. Why minus? Because this force is backwards. So 130 minus 65 will be 65. So it means the net force acting on the person is forward force of, we should also say the direction is forward. Anybody not following? I told you, I tried to explain it in the pseudo force concept, but it's slightly confusing. So that's why I said, okay, when we do the numerical, probably it will make more sense. Now look at the question. I told you to try this experiment with the pen and paper, right? So you keep the pen on the paper and then pull the paper. So if the pen is coming along with the paper, it means you are pulling slowly. If you pull the paper very quickly, right, the pen will slide backwards. Why? Because it's experiencing a pseudo force. Or due to inertia, the pen remains in the same place, whereas the paper got accelerated very quickly. Okay. So if you understand the paper and pen situation, you will understand all these problems: trolley and man, conveyor belt and man, all these things. The concepts are same. Up to what acceleration of the belt can the man continue to be stationary relative to the belt? So they're asking, if I keep on increasing the speed with which the paper is pulled, up to what speed this man will be coming along with the paper or the belt. So there is going to be a maximum acceleration. So you know that the answer is very simple. As long as the friction is able to hold him along with the belt, you will be able to come along with the belt. If the friction is, if the force is more than the friction, right, then this guy will not be able to come along with this. So take it down properly. So when the pseudo force is more than the friction force, right? What will happen? This backward force will be more, which means this guy will get pushed backwards or fall down. Okay, that's what will happen in a conveyor belt if the belt suddenly starts, right? Imagine that you are standing and if they suddenly start the belt, you will, it's possible that you will fall backwards. If you don't hold anything, you will fall backwards. So this is a maximum situation, right? Or extreme case for maximum acceleration of the belt. So F friction, you found it as 130 Newton. So there is no change in that. F pseudo is mass into acceleration. Well, you may be wondering, sir, why can't I use just this F pseudo MA? Well, they are asking you to find the maximum acceleration, which means you are not supposed to use this previous question. This is the second question. So this is the B part. This is the A part. So mass is given 65 kg. So A is equal to 2 meter per second square. Again, just for an additional information, meter per second square or meter second power minus 2 both are same, but this is usually accepted. Okay, so in the modern days, everyone has started using this one. They don't use this one, but for some reason, I find it very comfortable with this one. So it makes more sense to me. Meter per second square. But in your exams, it's better to write it like this. Okay, but of course, nobody is going to object, if you write it like this. Any questions? This is the maximum. So if you go beyond up to 2 meter per second, if the belt is accelerating, this guy will come along with this belt. If you go at say 3 or 4 meter per second square, this man will fall backwards. That's all. Any questions? Take it down. Very, very simple. Nothing very difficult. Only the concept you need to think. Again, I've been going very, very slowly because it's a very, very important chapter. Most of the later topics will be based on this chapter. If you don't know this chapter, if you're not comfortable with the problems in this chapter, physics is going to be very difficult for you. So please take some extra effort. It's very, very simple. Okay, I'm going very slowly. Okay, anybody still copying? Chaitanya copied. Okay, very good. I would say this is an easy one. Try it yourself. Okay. So helicopter mass is also easy one, but I can give you the methodology. Imagine that I have a helicopter like this. Okay, something will be spinning here and something will be, the blades will be spinning here. There will be some stand over here, right, like this. So helicopter of mass 1000 kg rises with a vertical acceleration of 15 meter per second square. So that means it's rising up with 15 meter per second square. The crew and the passengers weigh 300, which means 1300 is acting downwards. So 1300 kg, and don't forget this is only mass mg, which means into 10, which means the force acting downwards is 13,000 Newton. The crew Give the magnitude and direction of the force on the floor by the crew and passengers. So let's say the crew and the passengers are sitting like this. So okay. So that means when I'm sitting here, I'm going to experience a reaction force here, right? R. And then this is mg acting downwards. Okay. So force on the floor by the crew and the passengers. So force on this thing means sigma F is equal to ma, most important formula. I'm talking about the first one. So R is upward reaction force, R minus mg is equal to ma. R is the reaction force, minus m is mass of the crew and passengers, which is 300. So 300 into 10 will be 3000. Mass is again 300. But then the entire helicopter is accelerating by 15 meter per second square, right? So it's something like your lift problem. So this is accelerating upwards. A is equal to accelerating upwards. So that means this will be 15 acceleration. Upwards, yeah, upwards, so it's positive. So R is equal to 3000 plus 300 into 15, whatever that is. So I think you'll get 7,500. Is that right? 345, yeah, 4,500. So 7,500. So this is a reaction force from the ground. So what does that mean? If I'm giving certain amount of force on the floor, then the floor is going to give me, again, we are talking about the floor of the helicopter, okay, not the ground. That means the reaction force is upwards, but then that is the force which you are giving downwards. So in other words, since the lift is going upwards, what did we say? We will get pushed downwards. When the helicopter is going upwards, we will get pushed downwards or towards the floor, which means the floor will be experiencing more than the gravitational force. That's why it becomes A plus G. Any questions? Action of the rotor of the helicopter on the surrounding air. So action of the rotor of the surrounding air. So action of the rotor means the rotor is going to be spinning like this, which means is it pushing the air downwards or upwards? The helicopter is going upwards. What is the
Downwards.
The air is getting pushed downwards, right? Something like you're swimming, Newton's third law. Okay, if I push it downwards, I'll be able to go upwards. So action of the magnitude and direction. Here I didn't tell the direction. So since it is on the floor, it is R is upwards, but then they're asking force on the floor by the same. So this is a reaction. So the action is you are pushing it downwards. So this take it as reaction. So action would be the force by crew and passengers on the ground. So the direction here will be downwards. Here this is upwards. This is downwards. So the rotor is pushing the air downwards, right? So that means this is air particles are here. So that is getting pushed downwards. This is your rotor. So the rotor to air is downwards, whereas the air will be pushing the rotor upwards. Okay, so what I am trying to say here is this is rotor to air, or you can say rotor on air. And then the force is air is pushing the rotor upwards. Since the rotor is getting pushed upwards, the entire helicopter is rising upwards because rotor is the helicopter is connected to the rotor, which means it is a action and reaction pair. Here also it is the action and reaction pair. Okay, this is B part. I'm talking about the B part here. So the reaction is happening upwards, the weight is acting downwards. Then the entire helicopter is getting raised up with an acceleration A. So I'm going to write it as R minus mg. Okay, R is upwards, mg is downwards, and the acceleration is upwards, mass into acceleration. After that, it's very simple. So that means R minus m is 1300 because helicopter plus the people. Into 10. So mass is again 1300. Acceleration is plus 15 upwards. So do the math. I think you should get 325. So you can double check it. You can take it down, but you can double check it later. So they're asking you to calculate the action of the rotor of the helicopter on the surrounding air. So that means they're asking you to find this one. But what we have calculated is this one. But you know that this and this are equal and opposite. So since I don't have a way to calculate this, I can calculate this one, like what I did here. Anybody not following anything? Please stop me. Simple concepts. Action and reaction pair, will they act on the same body or different body?
So on different bodies.
Different bodies. If it acts on the same body, can you call it as action reaction?
No,
So
sir.
No, right? So if it is acting on the same body, you would not call it as action and reaction pair. That's all. So the R, so the rotor to air, it will be downwards. This is upwards, right? Rotor to air force is downwards. B25. Any questions, anybody? Force on the helicopter due to the surrounding air. Well, that's what we calculated here, right? Force on the surrounding air due to the, force on the helicopter due to the surrounding air. So that means this and this are equal, right? This is upwards, this is downwards. So C part is nothing but the same answer. Only thing it will be upwards. Here we are saying this is downwards, which means the C part will say downwards. Any questions, any doubts? Sorry, C part will be upwards because the air is pushing the helicopter upwards. Can I move on? Any doubts? Okay, any other problems which you tried, not able to do? The coin, these things are easy, so you can try it yourself. I'm interested in doing this problem, the picture problem. So let's try to understand. So look at this case 1 and case 2, right? Case A and case B. Can anyone tell me which one is good or which one is bad?
So the first one is bad, the second one is good.
Second one is good. Okay, why? Because in the wells you have seen this kind of pulleys, right? But
Yes.
why do you think this is better than this? Here also you are pulling 25 kg. Here also you are pulling the same 25 kg.
So we can apply force in our easy direction, sir. So the effort is needed lesser.
Okay, very good. Partly correct. Effort will still be the same. Only thing the direction has changed, right? So pulling this block upwards is going to be very difficult. Whereas pulling this block downwards is easier. Why? Because your weight is also helping you to come downwards. Everyone following what I'm saying? So the force on this rope and the force on the rope will be the same. Only thing here you are pulling it downwards. It's easy for you to hang on the rope and pull it downwards. Even a small child can, try to hang on it and try to pull it downwards. But this is not like that. Do you agree, Roshni?
Yes, sir.
That means it helps you, the pulley helps you to change the direction. Okay, let's try to understand from the Newton's laws of motion concepts here, why this is better than this. Okay, you already know intuitively, you know that this is bad and this is good. So let's try to understand from a physics perspective. Make some rough diagrams. Okay, without diagrams you will not understand anything. Somebody not muted, I think. If you're not talking, please mute. Okay, color. Okay. So listen carefully. This man is standing here, so the center of gravity is, acting this way. So the man is 50 kg, which means 50 into 10 mg is acting downwards, so 500 Newton, right? And the reaction force will be upwards, R. Okay. And then look at this. If I say 25 kg, so look at this carefully, very, very important concept. I told you many times. If I cut this rope, right, this will fall down, which means you agree that the tension is holding the block upwards, right? So similarly, this guy, right, this tension is, from the perspective of the block, the tension is acting upwards. From the perspective of the man, right, this string is pulling him downwards or upwards? What do you think? This weight is pulling him downwards or upwards? Downwards, right? Which means the tension is actually downwards. So this is the confusing part. So we will show the arrow this way and this way. And very often I have seen students getting confused, sir, why are you showing it like this? And the answer is, this is for the block. So take it down properly. Make some simple diagram for the block, tension is upwards. For the man, tension is pulling downwards. Is pulling downwards. Okay, so very important concept, so take it down properly. So suppose if I draw the weight acting on this block, you know that it will be 250 Newton. So tension is acting upwards. So that means I can say that tension is acting upwards, 250 Newton is acting downwards for the block. What do you call this? It's called the free body diagram of the block. And then I need to draw the free body diagram for the man. So you know that the reaction force is acting upwards, the weight is acting downwards, 500 Newton. And then what else is acting? This rope is pulling him downwards. So this is extremely important. So take it down properly. From this I can say T is equal to 250. I don't think you need any explanation for that because there is no other force acting. So since the block is hanging in there, this and this should be equal. So if I say that this tension are same because it's the same rope, then I can put it over here. That means 250 plus 500 will be 750. So R is equal to 750 Newton. Okay. Or if you want, you can write one extra step to make sure you don't forget. 500 plus T. So 500 plus 250. Okay. So that means the reaction force from the ground to the man is 750 Newton. Any questions? Now let's go to the second. So take it down. This is what is the action on the floor by the man in two cases. So we found the action on the floor by the man. So we found this for the A part first. Let's do the same thing for the second part. Let me draw it in a different color. So this 250 is same. This tension is acting upwards. Whereas this person, now look at this. I'm pulling it downwards, which means the rope is actually pulling me upwards. Okay. This might be slightly confusing, right? Here, if I leave it loose, right? If I don't hold it very strong, what will happen? The rope will pull me downwards. Here, if I don't give too much of force, right? The rope will slightly lift me upwards, which means the tension is actually pulling me upwards. This is the point where you need some imagination. Okay. If you don't give force downwards, the tension in the rope will try to pull you upwards. Weight is always acting downwards, so no difference here. Reaction forces upwards. So this is same, T is equal to 250. Nothing changed here, right? So look at the diagram now. Here the tension was pulling you downwards. Here the tension is pulling you upwards. So that means T plus R is equal to 500. Tension is 250, R is equal to 500 minus 250, which means 250 Newton is what is your reaction force. So we talked about, we said this is bad and this is good because we thought, okay, the tension in the rope, I can pull it downwards, which is much easier than pulling this bucket or block upwards, right? But read this question. If the floor yields to a normal force of 700 Newton, what do you mean by normal force? So this is the force which is from the floor to the man. So listen carefully. This force is acting on the man, but where did that come from? Because of the contact with the floor. So it means floor is giving a force to the man. Okay. So a bit confusing, so pay attention. If the floor yields to a normal force of 700 Newton, what do you mean by yields? Anybody? Yielding means breaking down, right? So it's kind of collapsing. So if the floor collapses, right, then it's much more dangerous. So look at this reaction force. Here the floor will be giving a reaction force of 750 Newton. Here the floor will be giving a force of only 250 Newton. Why? Because the tension was acting upwards. So I was actually getting pulled upwards. Here I was getting pulled downwards, which means the floor, the possibility of floor breaking down here is much higher here compared to this one. And that's the meaning here. So look at this. If they say that the ground is going to break at 700 Newton, here it's already 750 Newton, which means there is a possibility that most certainly this will break, which is dangerous. Here, that situation will not arrive because compared to 700, this is giving you only a reaction force of 250 Newton. So that means B is the best method. Anybody not following any questions? Very important question. Okay, both for your school exams and entrance exams. Simple addition, subtraction. If you know the concepts, if you know how to do free body diagram, these are all easy problems. Otherwise, it's very, very complicated problems. Okay, so any doubts? Anybody? How many problems did you do? 1, 2, 3, 4, 5, 6, 7. Okay, so we have done 7 problems. Not bad. 7 or 8 problems, I think. 7, only 7. Okay, that's not bad. Okay, again, as I told you, I would like to go a little bit slowly so that you folks, feel comfortable. Your homework is to finish whatever we have left in between. Try to do that. Everything, it will look complicated, but it's actually easy. So take some effort. Maybe this coin problem might be slightly confusing. I can help you. This is very, very simple. You can do it. Monkey problem. I already told you in the theory. This one I given the theory in the handbook. So try this. This one is trolley problem. Instead of trolley, it's a lorry. That's all. So the lorry will be accelerating forward, which means this block will go and fall down backwards. That's all. So try this yourself. So take it down. Your homework is 36. 33 is easy. 36 is medium. Try it. 35 is also easy. 34 difficult, but try it. Okay, you should put a reaction force between A to B from the wall. Go back and study the theory in the handbook. The 34 is medium. These things I can help you later. And then all the problems in between this and this. So page number 111, 111 and 112. So finish all these problems. Okay, I'm going to stop here. If you have any doubts, stay back. Otherwise, you can leave. Thank you all. Please start doing the problems. I will be giving you an online assignment very soon. Okay, thank you all. Bye.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you, sir.